Hello, good afternoon, everyone. Hopefully you all enjoyed lunch and you're ready to go. So let me know if you can't hear me, just like maybe do like this or something so I speak louder. My talk is on manual JavaScript analysis is a bug. I've given this talk before, but this is like I gave it back in 2018 before the wonderful world of COVID. So I've had some time to think about like how this could be improved, and there are some various improvements to the talk. So just a small little bit about me. I'm a lead. I just recently joined. Yeah, let's get this closer. Just recently joined Salesforce a month ago, and I joined as a lead security engineer. I'm working on a team called RedScar, which essentially works at trying to help reduce vulnerabilities at scale from things like guardrails, automation, etc. I don't have any like fancy plugs or anything, but we are hiring if you are looking for a job. We are, US and other, realms around the world. I'm also one of the OWASP San Francisco organizers. I've been doing that for quite a while. Haven't really been in the Bay Area that much recently, but still try and help out when I can. I did a degree in ethical hacking, and then during that time I had a lot of fun like being the president of the Ethical Hacking Society at Leeds in the United Kingdom. More recently, I have been running a Security and Crumpets podcast, which I'm very proud of, under the YouTube handle and Twitch handle Carl Baskin. It's a long story, ask me about it later. And also the Twitter handle Security and TNC, and it basically brings various people from different backgrounds in the realm of application security and information security, and basically just ask them about the background, do different tooling. Some of the stuff you'll see today, I've had the people that are like the lead people that are building those tools, etc. on. It's been pretty fascinating so far. So today I'm going to have a bit of an agenda. So first we're going to dive into what is a bug, well, manual work is a bug, and what do I mean by that? We're then going to dive into what can and should we automate, because a lot of the things that we do on a day-to-day basis technically can be automated and should be part of our workflows. And obviously, I'll show some of the things that exist today. Some of them are in a commercial sense, some of them are in a free sense, and I'll try and make sure that I talk about those interchangeably so you can get an understanding of what you can use today and what you might have to pay for. And also a free proof of concept app that I've been working on and off for two years. Took a bit of a hiatus between COVID, but hopefully I can get the momentum to continue it. So this is quite an interesting kind of philosophy. There's a wonderful paper from a person called Thomas A. Lemoncelli, which is a great last name. Reminds me of limoncello, and limoncello is delightful, so it's pretty great. But he wrote a really interesting article that basically was titled "Manual Work is a Bug," and he goes into detail about these two engineers. These two engineers both have the same type of skill set, but one of them was deemed more successful in the field for some reason. And the reason why, even though they were equally as talented, the person that was deemed more successful was because of their iterative process of automation. Automation isn't always a lifesaver. Sometimes you do a task once and then you walk away. That's perfectly fine. But for a lot of the work that we do in application security, we really want to think about how can we automate those things to be able to challenge ourselves and find more issues that we may have not found due to trying to just do the repetitive tasks. But the blog post goes into a lot of detail about how you would document and go down that process. Now, the first thing is basically document the steps. And this is like your brain just writing it down from your brain into paper. And this basically is where you are the CPU and you're writing step-by-step guides on what needs to happen. And a few examples of this could be very basic to begin with. It could be basically you're searching for DOM XSS and you want to look for these particular patterns. Then you want to create the automation process or the equivalents, and that basically could be snippets of code, or it could even just be simple command line arguments for a tool that you run on a day-to-day basis, like mmap. But let's just keep the DOM XSS scenario, let's say starting the automation process, you were manually searching for these particular payloads. Now you might want to start building static analysis rules to try and identify those locations for you. And then you basically want to create the automation. So you start leveraging the tool to try and identify those issues. Rather than looking for it manually and scanning individual code, you just scan a code base and try and find those bugs. And then finally, you want to get to self-automation or a standalone tool where you can automatically either give it a URL to try and find DOM XSS via headless browsing with things like Burp Suite, or automatically try and find DOM XSS and iterative improve those static analysis rules over time as either a self-service or as an autonomous system. Now, one of my good friends, Parsia, wrote a blog about this, and his name isn't actually Parsia Hackerman, it's Hackerman, but I mean, he dressed up as Hackerman for Halloween once, and I'm sticking with that. So he basically wrote a blog post, which I would highly recommend you checking out if you're interested in this kind of realm. It basically goes into a lot of reflections about like automating everything you can. Everything is just a series of manual steps in your documentation with a bunch of code snippets. Let your mind be the CPU, follow these directions, and improve them when you can. And in his blog post, he goes into detail about like every time you think of a new idea or a new update to like your process, update that immediately, otherwise you won't do it. But I have a pretty fun backstory about Parsia, and we both used to work at a company called Cigital that eventually got acquired by Synopsys. And basically, whenever someone had a question about thick clients or like kind of testing like Java applications, for example, he would always ask the question like, how do you do X, Y, and Z? And normally the response to most consultants was, have you asked Parsia? And that's because Parsia internally was working on this thing called the Parsia clone. And the Parsia clone was basically, he wanted to make himself redundant. He didn't really want to, basically always answer the questions. So he built this Parsia clone, which was basically a wiki trying to clone himself for like things like how to use a tool, how to intercept, traffic in a thick client, how to add certificates to your Java store, etc. And obviously, writing down the ways to do that, you can obviously eventually start to build automation into your pipelines to try and do that yourself. So that's basically where that kind of side came from. And this is my own personal philosophy. The more things that you can automate will allow you to spend time looking at more interesting bugs, in my opinion. So automation will allow you to look for like business logic flaws. It'll allow you to identify more attack chains as well, because there have been a lot of scenarios where I talk to a lot of consultants and I see their reports when I used to work in consulting. And a lot of the time they would found like 17 instances of XSS, and they did that manually. They were testing it dynamically, etc. And that's great, but they could have spent a lot more time like finding a few instances or trying to automate finding all the instances and then spending more time finding other bugs. So now let's move on to the fun stuff. What are the types of things that we should automate, or what we can, but technically should or already are there? So I have quite a few GIFs in this, or as someone said earlier, GIFs. I'm OK with both interchangeably. I think a good place to start with is that we shouldn't have to, with inside web applications from both a dynamic and also static analysis perspective these days, we shouldn't have to try and look for basic sources and sinks. Obviously, if this is a new concept for you, that's fine. A source is basically anything a user has control over, and a sink is anything where malicious input can cause undesirable effects, like cross-site scripting. When we think about the JavaScript land, there's many common sources that can come from places such as response.txt, which basically when you perform a cross-origin resource sharing or XHR request, you basically get this response text, and that technically could contain user data. You have event data from things like post messages. You have the window location.hash, which obviously is controllable by a user. And obviously you have things like cookies, like local storage, IndexedDB, all of those wonderful things in the browser. And obviously a common sink would be things like dynamic evaluation of JavaScript, such as eval, etc., inner HTML, window location, href obviously allows you to, even though it technically can be sometimes the source too, but window location.href obviously can lead to like things like JavaScript URIs. So in reality, we shouldn't have to look at these things, at least from either a detection and also a trying to find vulnerability state. Now, today's modern world, obviously, my personal recommendations are to leverage things like semgrep and burp suite. So you can also use, obviously, Zap. Zap is a free OWASP project. It's very good in its own right. But there are a few things that it lacks, and that's why I'm recommending burp suite today. You should use them interchangeably. I think ultimately Zap's headless mode is really good for a lot of teams. I think the crawling aspect for most modern websites is the hardest part. But for detecting issues, I would recommend semgrep and burp suite. So when we think about semgrep, I class it as the go-to tool for making sure that code issues are squashed before you make them into a repository. It's very flexible, and that's what makes it really good. Like a lot of the time, static analysis tools, and sorry if I'm speaking fast, I'll slow it down a bit. A lot of the time, static analysis tools tend to be quite problematic in the sense that they're really hard to understand from writing a rule, like your own personal rule. or they're over complex, or they don't allow it. So there's some companies that think that the vendor themselves should be the golden source of truth for finding bugs, which obviously a lot of people probably don't agree with, myself included. That's from the static analysis perspective.
Is set-drift kind of like checkmarks that it's static code now?
Yeah, it's similar. So it basically can obviously pass an abstract syntax tree. It uses an open source tool called tree sitter, which basically allows you to get like the language specifications for a language, and you can easily build on top of that. So it is using open source tools. Obviously, it's an open source product. So you can take a look at all of the code, apart from maybe some of the private repository stuff and like their commercial aspects, which technically that's just like if you want to have all of your data going into like a dashboard and stuff.
And it's completely free.
Yep, completely free. Obviously, Burp Suite has a community version, and I'm going to talk about some of those components too. So for me, like the one way I generally try to find issues now in today's code is basically leveraging semgrep. I would class it as a Swiss Army knife because you can extract out information regarding an application, which I think is very valuable because you can use that and put it into other tools. You can use it to identify security issues in source code. You could even use it for quality issues and other aspects too, and even like missing like authorization checks in your code base, which I think is very valuable. And you can combine it with other software. So as you can see here, like this, the rules are really simple in nice, simple language. I'll be the rock star. So obviously you have things like you can define a rule. It's all in YAML. You basically define your ID with what kind of message you want. This can contain like meta variables and stuff. You define your languages. It can be many languages. It could be like regex. It could be HTML. It could be JavaScript. It could be Go, etc. And then you build patterns. And this is all just the same language and the same coding that you would generally see. So I think like a lot of tools kind of are super complex and it's really hard to write the rules. But personally for me, I think it's one of the easiest ways to get started trying to find bugs. Now, another way is basically leveraging something like the Burp automatic scanner, which obviously is a paid product. Realistically, you could use the Zap version too. Zap has its own automatic scanner for trying to find like DOM XSS, but I still think the Burp scanner is a little bit more ahead of the game, realistically, because it basically allows you to identify the sources and sinks, which obviously is very valuable. So and obviously the two types of things that it identifies is normally basically JavaScript injection. So you already have basically the ability, you're inside a JavaScript function and you have execution there. Or there's things like inner HTML assignments where you're taking over the HTML property, which allows you to inject malicious code. Now, something that's like super new and super interesting from my perspective is the DOM invader. It's nothing kinky, I swear. The browser realistically should be leveraged to detect different types of document object model issues. And this is my personal philosophy because the browser knows how to render things. The browser is easy to like iterate over. You can interact with the DOM at runtime. And if you don't leverage things within the browser, you will miss a lot of bugs. So anything like post-message evaluation, anything like DOM-based assignments, variable assignments, etc. You can find this all in the world of the browser. Now, what a lot of people have done is leverage things like this. So as you can see here, what Burp Suite have done, and this is also in the free version, so you can use it in the community version. So you shouldn't have to manually go and look for arbitrary sources and sinks. When what you're seeing here is that you have the location.search and the URL params. That is things which are in the query string, which are going into like what we class as sinks like document.write. So as you can see here, you can add canaries, and the canaries are basically used to try and identify where things go from a source into a sink. And you can choose like inject canary into URL, into forms, etc. So it tries to automatically and auto-magically try and find where those sources and sinks interconnect. Hopefully I can make it back to my presentation. Cool. So the reason why I still recommend Burp to be one of the best kind of things is because it also detects out-of-bound responses. And you can't really do this without having an automation pipeline. So when you think about out-of-bound responses, it's like you inject some data into a backend service like an admin portal, or like something which you generally don't see, like a customer support portal, something like that, which a user would not see. Now, you can find like different types of vulnerabilities that then can be leveraged to ping back to your own systems. And Burp Suite has something called the Burp Collaborator, which allows you to identify different types of vulnerabilities, such as like XXE, server-side request forgery, blind XSS, and blind SQL injection, for example, because it may happen, and you might be able to like use that SQL query to make outbound calls. So, and this is like really interesting. So, one of the things that I think is kind of like underappreciated in the world of application security is basically detecting out-of-bound responses such as like blind XSS. And this is of course when you find a cross-site scripting injection that ultimately leads to execution inside a context that you can't see, and then it ends up coming back to your server later. So Burp Collaborator does detect blind XSS. However, it only has a couple of payloads. And in today's modern web applications, you have various different frameworks that render HTML properties different, such as like AngularJS and those, and like Vue.js, for example. They take mustache templates, they take HTML properties that like could be evaluated in JavaScript. This is known as it'll come back to me. But anyway, so the first initial tool that was used for blind XSS was technically a project from Netflix, and it was called Sleepy Puppy. That got deprecated a long time ago, and then basically XSS Hunter was made by Matthew Bryan, who I believe works at Google, may have left it, used to work at Snapchat too. His name is on Twitter, he's Mandatory Programmer, and also on GitHub. He created a project called XSS Hunter that allows you to like set up your own subdomain on the website, and then basically copy all the payloads and then use those to try and find blind XSS, and it would automatically tell you about the blind XSS issues. Then the reason why I said top dog and hot dog is because I created the second one, which is basically BXSS. It basically tried to go that extra step further to be like super or automatic, and in the sense of like it will try and identify a well-known .security text, which allows you to like retrieve that information and then automatically send an email address and an email containing the payload to that security contact, which I thought was like pretty interesting, and also added text message support, Slack support, and all the other things like Teams, which the parsing of Markdown is horrific there. So I would highly recommend like leveraging things like XSS Hunter or BXSS to try and find out-of-bound responses. And again, as I said, you want to make these things automatic. So initially, the Sleepy Puppy team created a Burp extension that would like look for initial payloads. But I basically hacked it together so you could define your own payloads, and also like the domain, because otherwise it was always trying to link back to theirs. So it's still I wrote it a couple of years ago. It will still work, but it could use some TLC. But what it does is you can define your domain, and then you have a list of payloads. So you have like different, base href, which bypasses a lot of CSP policies. You have like all these different things like, mustache templates for bypassing things like Vue and AngularJS. But what I would recommend if anyone wants to take on a project is to go to the Portswigger's Web Security cross-site scripting cheat sheet and build a project that will arbitrarily make blind XSS payloads for everything that exists there, because it's a very exhaustive list. People still use deny listing in like admin pages, etc., and also allow listing. And you might be able to like find a bypass by leveraging some of those payloads. Okay. We also shouldn't have to manually identify URLs and assets that exist inside an application. I don't want to be looking at minified JavaScript for the rest of my life and like searching for HTTPS pages, etc. And the reason why you want to do that, and it's very important, is because you can find unauthenticated or admin APIs. You can find other domains which might be accessible from either an external presence, or if you find server-side request forgery in your current application, you might be able to leverage that to query some of those domains that you found. So there are obviously a lot of various ways that you can do this. And the first one that I would recommend is basically called endpoint discovery. So it's a JS link finder. And basically you can use it to pull out from all the JavaScript files different like endpoints. And this was just, I went to a random AOL website, and obviously it pulled out all of the admin pages, it pulled out the developer portals, etc. So I would highly recommend, if you're ever like doing like a pen test and you have your scope defined, or if you're looking for hunting for bugs, you really want to take a look at what's on those JavaScript pages and what links exist in them, because they'll have dev instances, they'll have like various different instances that could be used to gain extra attack holds into that application and also that organization. So that's from like when you're browsing with like Burp Suite. I couldn't find a Zap alternative. I don't think it exists, but if you do find one, please let me know, because I would love to update this slide. So that was from the dynamic presence, because it's doing it via its proxy, and like when it's like loading all the pages via a proxy with Burp Suite. But you can also do this for source code as well. So a lot of the time, you want to find like the interesting URLs, etc. And the one way to do this is to use something like semgrep. Semgrep is the reason why you don't just want to use arbitrary grep is because you can really filter out the types of things that you want to find. So as you can see here, we're saying we want to find any HTTP or HTTPS request inside literal strings. And as you can see, it only flagged 1 and 2. It didn't flag the comment, which I think is super important from an attack perspective. And a lot of the time when you're reviewing applications, especially in production, you get access to the bundled files, which you're not going to be able to read. It would take forever to reverse engineer it to be able to actually manually review it. So a lot of the time in production, it's very useful for developers to have access to the source map. And the source map is essentially, it's basically the reference points to the original code that was used before it was bundled up for performance, etc. Because you normally want to expose those. Well, a lot of people do expose those on the internet. And it's obviously used for like performance. And obviously there's many different minification processes that exist, like Webpack, Rollup, and Parcel. But obviously you don't want to look at like this miniature code, right? You want to be able to get back to the original content. Thankfully, the browser is one of the most useful tools you'll ever use in an application security testing experience. If you're not leveraging the developer tools and you're trying to do application security, I would recommend that you invest some time in getting really down into the weeds about how the developer console works and how to leverage its capabilities through its debugger capabilities, etc. 99% of the time, you can just go to a website and you can find the bundled sources and get back to the original source map, which allows you to see like the actual like CoffeeScript or JavaScript that actually was, or TypeScript original definitions. And there are many sources. You can do that normally in the browser. When I've done like pen tests for clients back in the day, and there were a lot of times where Webpack was a bit weird and the browser couldn't quite understand it, so it couldn't depack it for you. So you can leverage these other tools, such as like the Mozilla source map or the Denan's source mapper that's written in Go. That appeared to be the most accurate one to actually be able to undo this. And a good thing, if you are using Burp Suite, there is a Piper script, so a custom Piper script, which basically the Piper scripts are basically used to try and find relevant information about an application. And they basically have this thing called extract SPA low-hanging fruits, and that will automatically tell you if it finds the reference to a source map, which you then could use to either open the developer console, try and get back to the original source, or use the unpacker. And of course, when you're testing applications, you want to test it correctly. A lot of the time, if you're testing like a AngularJS application or a React application or a Vue application, there's going to be different things that you look for, right? So like if you're just looking at trying to attack it like a vanilla JavaScript, like an original JavaScript application, you're probably going to fail to find a lot of things. So I would highly recommend leveraging extensions. I actually found one for Zap, so it is free. The Wappalizer extension for Zap allows you to basically identify different JavaScript frameworks, like if it's been bundled with Webpack, what kind of JavaScript libraries are being used, like jQuery, etc. You can also use Burp Suite's asset discovery package to find these types of things. And obviously there are browser extensions like the Wappalizer browser extension. And then there's also JavaScript. Obviously, if you're looking at the source code, you have access to the package.json file, the bower.json file, and all these different things that allow you to see what kind of dependencies are being used, that obviously allow you to understand the technology that's being leveraged within that application. So this sometimes allows you to understand they're using S3 as a hosting provider. It allows you to find, like maybe if it's powered by with the X header, what kind of technologies like Angular. So like if I knew they were using Angular, I knew I would be looking for like, bypass security trust. If it was AngularJS, I knew I'd be looking for basically anything to do with jQuery, because that leads to issues, and also anything to do with the embedded APIs that exist, like trust as HTML. We also, in today, like the reason why in JavaScript specifically, this is like one of the more dangerous vulnerabilities, is that we shouldn't have to manually find hungry regular expressions. And the V8 engine, JavaScript itself, is basically a single-threaded platform. If you block that through things like like encryption, or like doing large iterations for like password hashing, using like high iterations of those things, you can slow down your application, because normally those happen in a synchronous way, and they're also happening in the sense that it's single-threaded, which means it blocks the event loop. And you never really want to get to the point where you can block the event loop. The problem with common JavaScript applications, this can happen both from a client-side perspective and also from a Node.js perspective. This is because there was actually a vulnerability in AngularJS that led to something called HangularJS, where you could provide like a malicious or a vulnerable regex that would actually hang the entire solution via user input. There was also, obviously on the Node.js side, if you are doing like a regular expression to test things, you could lead to ultimately finding that your application ends up just grinding to a halt. So we shouldn't have to manually find the instances of regular expressions, and there are tools today that exist that can help us find vulnerable regular expressions. So in this case, you can see that this is a very simple piece of code. We define a regular expression, we're testing against a string, and ultimately, because the way that that regular expression is written, it's basically doing like a lot of quantifiers with the plus. If those two are used in conjunction, it basically makes that string take a lot more steps than it probably should have done if it was written correctly. So obviously that would lead to regular expression denial of service. So there is a wonderful amount of resources in today's ecosystem that you can use for automation for detecting these things. So if you've never looked at the Usenix post before, I'd highly recommend it. But there are a bunch of open source tools that you can leverage today to find different types of regular expression vulnerabilities. We'll let the gentleman take a photo first. And then, this is my personal approach. So the way that I do it, and the way that I don't do that much pen testing these days, but the way that I would personally do it is basically extract those regular expressions with semgrep. So review an application, find all of the instances of the regular expression usage. Pass those expressions that were found from semgrep into the recheck tool, which is one of the ones that I mentioned on a slide. The slides are going to be available online, don't worry. And basically then combine the output from those two things. So you can define that you know exactly where the code, where the issue is, you know which line that vulnerability is on, what is the regex, and what is the status. I actually tested this with the node modules enabled, and I kind of went a bit over the top. So I have the wrong one over here. And it found like in a node module, the actual, you can see it there, like one of those is a node module, and it actually found a potentially vulnerable regular expression. Doesn't mean it is vulnerable, but okay. I'll show you that at the end. So yeah, that's what I would recommend, using semgrep and also recheck. You could obviously use various different things. You could just use grep if you wanted to. There are many different ways to do it. This is my personal approach. There are many services that we interact with as developers, and also applications that are leveraging services, like being able to access your GitHub repository, RSA tokens or RSA keys for like, being able to encrypt data, passwords to interact with services where you're either logging information or interacting with the service to get more information. And obviously you'll see now on like github.com, they automatically scan for these types of things. But obviously there is, always going to be that issue where it might have a different naming convention. It might look a little bit different. So we can still find automatically secrets. And there are an abundance of libraries that you can leverage to find secrets. So one of these things is like, one of the more popular ones is like Trufflehog. The Ed Overflow blog post basically goes into a lot of detail about using ripgrep and get secrets, so ripgrep. But my recommendation today is to obviously, because I'm probably a semgrep fanboy, I do not work for them, is to probably leverage semgrep secrets. And as you can see, like at the top, that's the output from leveraging semgrep's secrets. We also shouldn't have to manually identify known security issues in third-party libraries. There's also always those wonderful images where here's your application, and here's actually the code that lives in it, and 90% of the time it's like node modules is like 80% of your app versus that 20% which actually is your code. So obviously today we have an abundance of ways that we can identify different issues with those third-party dependencies that we leverage with. And it's obviously there are like commercial products, and I don't want to get into all of that, which you can use snick test on open source. Obviously it has a commercial offering. There's also Synopsys Black Duck, etc. But if you're just starting out and you just want to see what your application ecosystem might look like, you can use the free applications such as npm audit and also yarn audit that can find vulnerabilities in your application. There's also like retire.js, which you can use part of your Burp Suite pipeline. Sorry. There was someone taking a picture. There's also like the retire.js, which I would say it's a good thing, but it doesn't have a big resource. Obviously, that's why commercial products exist today, with a lot of VC funding to be able to pump out those databases. But these are like really good starting points if you're ever starting to look at an application. So you can use retire.js in the Burp Suite sense. Obviously, you can use npm audit on the command line to try and find different vulnerabilities. You don't want to manually go ahead and go through every single one and try and find in the SNCC online website to see if it's vulnerable. That's too much time. You want to go fast in these types of things. This will all make sense in a second. So as someone who used to do a lot of pen testing, a lot of security auditing for a consultancy, it would be kind of awesome if you give your colleagues or testers basically a tool that could go, these are the kind of things that you want to test, but in code. So what if you could basically take a look at the package.json file and build out a list of things, or it could even be for Python, it could be requirements.txt, it could be a maven.pom, it can be anything. But like, what if you could get to the point where you, for particular very popular repositories inside your organization, as a pen tester or as someone who's doing on the security side or the red team side or blue team side, what are the types of things you might want to do in a review? So you could build an internal or maybe leverage some resource somewhere to basically build a potential configuration list for some of the popular dependencies that you use. So one of those things could be like you're using the SQL native driver. Obviously, you'd probably want to look for SQL injection. These are the semgrep patterns, or these are the patterns you might want to use to try and find different types of vulnerabilities. But obviously, this is what I think the output might look like. So if you have basically like a list of different things that you want to check for an assessment, obviously this is manual review, but at least it's going to give you the things that you need up front rather than having to go and dig for it manually. So imagine if we were looking at Express Session. There's many things that you want to look for. So this is what Express Session looks like. You have a bunch of things that you need to be worried about, like not storing a secret in source code, making sure that those secure flags are there for your application. So like you could do things like, never store the secret in source code. That's from a config file or a runtime environment variable. You obviously want to make sure that the browser only allows the cookies to be sent over a secure channel. So you can use the host flag, which requires secure set to be true. And you also need to define the path to be the root path, which means cookies are never going to get sent anywhere else. They have to be sent over a secure channel for every single path in your application. You also obviously want to prevent things like cross-site request forgery. So you would want to prevent inclusion of cross-site requests. So you would want to define things like the same site policy. So you want to include same site to be strict. There's lax and strict. There's like different definitions. One is like you allow I believe GET requests, and then strict is like we don't allow pretty much anything without passing cross-origin resource sharing. And of course, if you just had the default definition, you could potentially lead to memory exhaustion because you're storing everything in memory. So you'd want to use like a database or a different store somewhere. And then you could take that output that you've generated from your tool and go yeah, it uses a config file, it uses HTTP only, it uses secure, etc. And this would be a good way to have a check that even though this is a manual review, you would still at least have a better definition of the types of things you'd be doing. So this is my favorite GIF on the internet, so I just had to include it. So obviously I've talked a lot about a lot of different things, a lot of different analysis potentials from a static and dynamic presence. But what if you had a tool that combines all of those open source projects that can help you find application vulnerabilities and also points of interest? So for this, I created a very simple proof of concept application. It's still very experimental, so bear with it. But it's basically a meta-analysis approach to basically trying to find different vulnerabilities using open source tools. So everything is obviously free to use and will always be free. So the functionality obviously has that help drive secure development based through the package.json file. It just has the express session definition, but if that was extended further, I think it would be very useful. It runs npm audit, it runs yarn audit if it finds the package.json file or a lock file or something. It looks for secrets using semgrep. It looks for redos, leveraging the semgrep into recheck. It doesn't perform security linting anymore. It actually does static analysis. It used to use ESLint. Did not fix that slide. My bad. But it also now uses semgrep to find issues against an application. And there are some wonderful npm packages like the electronic, I can't even say it, but the WSEC tool, which basically looks for various different Electron vulnerabilities. So let's just take a look at a quick demo. If I can. And let's get rid of this horrible one. If I can find the mouse. All right, so I'm going to run it. Hopefully I'm still connected to my phone. But basically what it's doing is it's pulling from the semgrep registry at the moment, but basically it's looking. It looks at the package.json file, it begins an audit. It then basically checks the database for potential issues with the definition list, so express session, etc. It looks for redos. As you can see, it found that vulnerable expression inside my test code. Because I had the npm package Electron, it looked for Electron issues. Nothing existed. It also used semgrep to search for general patterns, and in that code I had the reference to the Amazon AWS ID and also account number, which obviously is fake in this sense. It's now also scanning the repository for vulnerabilities using semgrep. So obviously I already have the output up here, which might break when it's coming down, but as you can see here, we found the reference to DOM_XSS. It found the reference to some sandbox type issues in Node.js. So I personally think if you have a tool there you go, so I just found it as well. So I personally think if you have a tool like this, like Metasec.js, running part of your pipeline, or at least in your auditing process for a manual audit, I think it's really going to speed up a lot of things. Obviously, it's not a silver bullet. It doesn't find everything, but it's very extensible. You can write semgrep rules however you wish, from detection, pulling out information, leveraging it, and other things. So I can just quickly show the code for that, because I know we have 20 minutes. Sorry, sped through this talk. I got rid of a bunch of slides. Ooh. I can't. Tell you what, I'm just going to go to windowed mode. Oh, it's over there, isn't it? How do I? Okay, we're back, everyone. Right, so just to show what this might look like in code. So it's like SemGrep is very extensible in my opinion. So you can just like write very basic rules that look like this. Let's close this. So as you can see here, all I'm doing for this code example is basically taking, any assignment into the regex and then taking that regular expression value, and then you can use that as the message, or you could take the meta variables and then leverage that within inside your application. So you could do that for a various, degree of things. But yeah, hopefully that has been helpful. So. Screens. I'm normally a Windows fanboy, so this is showing my age. Hang on. All right, cool. So in conclusion, automation really helps streamline a work process in like a testing capability. To get the best results, you want to automate from both a static and dynamic presence. Do it in the browser, do it via a proxy tool, do it via the source code. And obviously automation, especially in the JavaScript space, can definitely help you identify issues. So automate and be awesome. Hopefully you enjoyed the talk. Any questions?
What's kind of your threshold when you decide you're okay doing something manually versus okay, I'm tired of doing this, I'm gonna start writing it all up? Was there a threshold what you tip over there?
That's one of the hardest questions you can ask. No, I think it's a really important question. So the question was around when do you kind of basically stop when trying to assess something? Because a lot of the times you're I think there's an issue here, haven't quite understood it. My recommendation is write a potential finding, saying there looks like to be something there, okay, and then move on. Because realistically for me, you could spend 2 days finally get it, but then you've wasted a lot of opportunity elsewhere. Obviously, we used to have pretty good partnerships with the organizations we were working with, and we normally could ask them to show us the code, or show us the code snippets that were lying behind that production application. Obviously, from a pen testing or a bug bounty perspective, you're not going to get that level of stuff, so you would have to smash through it. But from a consulting or an actual internal a member of an organization, you want to leverage what you can see. So. Obviously, and then the way that I would approach that is you finally figure it out, build a SemGrep rule or a pattern, because it's probably going to be exposed. You could use CodeQL, which is also free, but it's it's a bigger learning curve compared to something like SemGrep. And then leverage that to try and find different variants of the same thing in code bases. But for your thing, I would basically, if it's just a pen test or something like that, I would just write up a potential finding and move on. Okay.
So one of my friends said if you have to do something more than 3 times a day, he said automate.
I mean, technically, yeah. I mean, if you have to do it more than once a day, I would say automate it. But I mean, if you're doing it once, probably don't need to. Okay. If you're doing it twice, probably, it depends how long the task takes too. Some things you might have to have, sometimes you can do partial automation, so you can get half the way there and do the rest manual. It could be transforming data in a way to put into a report, or it could be, something of that nature to get to the, the information to then manually assess. But yeah, realistically, I think people probably have better definitions of this, but I feel if you have to do it more than twice, and it's happening on a daily basis, 100% try and automate that. Either submissions of Jira tickets, submission of bug bounty reports, anything of those types of things, I would try and automate.
Thank you.
Yeah. So any other questions? I'll be around with my mask on, so if you have any questions, come speak.